In this video, we will explain in a short and simple way how the MOOG range of steering and suspension components is built, and what technical advantages it offers to the specialists and the end users. Firstly, this range includes the following components: the tie rod ends and suspension arms, the stabilizer links, as well as both the suspension and steering ball joints and the axial rods. Within each of these product families, several improvements have been made to adapt them to the new MOOG Differentiation range products. We will now look at what these improvements consist of and what products they apply to. Let's start with MOOG's hybrid core technology. This technology incorporates a carbon fiber reinforced polytetrafluoroethylene bearing, better known by its trade name Teflon, and an induction heated stud. This induction treatment allows us to precisely select the degree of hardening of the surface of this ball pin, allowing us to vary the hardness of the surface of the stud, depending on the area we are studying. This confers more hardness to the part in areas where the tension is much higher, such as the spherical base of the ball stud in contact with the bearing, so that its resistance is reinforced while keeping the parts with less tension more flexible, preventing the part from becoming fragile to strong impacts while extending its useful life. Thanks to MOOG's hybrid core technology, the induction heated studs mounted in the new carbon fiber reinforced Teflon bearings offer up to 40% reduction in radial deflection, which is the measured variation in the diameter of the pin's ball caused by the stresses to which the metal is subjected during normal use. The quality of this bearing is key for the correct operation of the spherical bearing. This is due to the fact that the different high-intensity stresses to which the part is subjected can cause very high friction forces between its components, which end up generating premature wear of the bearing and the ball stud. This wear produces undesired play, which results in loss of precision, and therefore of control in the steering, as well as noisy operation, increasing exponentially the risk of an accident. Thanks to the revolutionary hybrid core technology within MOOG's differentiation range, these products provide more precise steering control, smoother and quieter operation, and a longer life, thus extending the life of not only these parts, but also the rest of the elements that make up the suspension and steering systems. The grease used has also been improved in order to protect the whole system against excessive friction and oxidation. This new synthetic grease offers better contact between the metal of the bolt ball and the carbon fiber bearing. It also provides a better damping effect when this unit is in motion and better protection against wear due to friction. When the grease is not in good condition due to the operating time or is of low quality, gaps appear between the ball of the pin and the bearing. In these cases, the grease does not adhere to the surface of both parts, increasing the level of friction, which quickly increases the wear of the part, producing the disastrous consequences mentioned above. The special additives in the new MOOG grease also prevents the penetration of foreign particles of moisture, mud and dust into the grease. The use of the new semi-synthetic MOOG grease extends product life, eases the assembly, while offering exceptional smoothness of movements of parts, resulting in a more precise, more reactive and with a higher level of comfort steering system. Another important factor is the need to use quality fixation nuts. Flanged and zinc flake coated nuts provided by the new MOOG Differentiation range provide up to 3 times more corrosion resistance than the standard hop-dip galvanized coating, allowing a greater contact area by having a controlled friction coefficient. This feature makes it possible to adjust the tightening torque precisely, thus ensuring greater safety in the correct operation of the steering and suspension assembly. Let's now look at a brief summary of the parts that make up MOOG's differentiation range, to better understand how they are manufactured and what technical advantages they offer over the competition. Let's start with the ball joints. These important elements are subject to high loads in the steering system. When they work correctly, these elements guarantees the stability and precision of all parts of the steering system. Based on the way they are installed, there are two types of ball joints, bolted and pressed in. The housings of the bolted ball joints are zinc flake coated. On the other hand, the press ball joints housings have a chromium 3 coating, a chromium plating process. They are easily recognizable by the light grey color of the coating. The combination of hybrid core technology and Moog's new type of synthetic grease provides a higher level of durability, comfort and safety. Thanks to hybrid core technology, twice as much bolt strength is ensured, reducing the increase in radial deflection, the clearance due to wear, by up to 40%. The new type of synthetic grease also provides optimum smoothness for the driver and ensures an easier installation. The flanged and zinc flake coated nuts provide greater precision in the tightening torque as well as a greater and more stable locking force. Most competitors and some original equipment manufacturers use plastic rings to attach the rubber dust cover. Initially, when the part is new, you don't notice a big difference. But this element is constantly subjected to great stresses that move the ball stud constantly in various directions. So, over time, those plastic rings wear out, give way and lengthen, appearing loosely in the plastic seal. These gaps allow external particles of mud, sand, dust and water to enter and rapidly increase the wear of the bearing and internal metal parts. For this reason, Moog uses metal sealing rings throughout the range, extending the service life of all its parts. Another important element in Moog's differentiation range are the link stabilizers. As we know in these elements, apart from their technical quality, the appearance is a key factor for the mechanics. For this reason, the cataphoresis coating was replaced by a chrome 3 coating that provides a first-class external view of the product. At the same time, the plastic caps behind the ball joints were replaced by steel caps. These provide greater resistance to impacts from external elements coming from the road. The link stabilizers also use synthetic grease, flanged and zinc flake coated nuts. Induction hardening treatment is not used as it is not necessary for the ball studs, as these elements do not experience high loads. Axial rods are under a lot of stress due to the continuous pulling and pushing movements they experience in the steering system. This is why Moog designs these elements using technology such as hybrid core, the new Moog synthetic grease and the flanged and zinc flake coated nuts, to ensure that the durability of the parts is at the highest possible level. These technologies also provide a reduction in driving noise and increase the precision and speed of response of the steering and suspension system. Safety, precision, comfort and durability are key factors in Moog's product design. Tie rod ends are another critical element of the steering system that also uses hybrid core technology. These important elements have the task of keeping the wheels aligned at the right angles. Whenever the dimensions of these elements deviate from the specification due to wear or to a wrong manufacturing process, variations in alignment angles appear, negatively affecting the safety, steering precision and tire life of the vehicle. These elements are subject to high stresses, so we need to be sure that they function optimally throughout their life. That's why Moog manufactures them with hybrid core technology, the new synthetic grease, metal sealing rings and flanged and zinc flake coated nuts. These combined technologies ensure the highest level of efficiency of the parts in operation and a long service life in optimal conditions once installed. Let's talk now about track control arms made of aluminium. We know that aluminium is a material widely used by car manufacturers in order to make lighter vehicles. The problem with aluminium is that this material is not as strong as the steel used before. We have to be sure that the surface is completely free of local stresses and small irregularities, because the cracks that end up destroying the part begin in those irregularities. To protect the track control arms from this undesirable problem, MOOG implemented sandblasting for the external surface of the aluminium parts. In this treatment, sand is projected at high pressure and speed against the surface of the part to release all those irregularities and local stresses. In this way, a smoother part not only lasts longer, but also has a stronger structure and better appearance. MOOG also designs these parts with hybrid core technology, the new synthetic grease, flanged and zinc flake coated nuts. These combined technologies ensure the highest level of efficiency of the parts in operation and a long working life in optimal conditions once installed. Wishbone arms are also critical parts since they support the weight of the vehicle by receiving the impacts of external elements such as stones or other objects found on the road. The wishbone arms are equipped with bushings that are fastened with external metal plates. MOOG has increased the quality of the materials used for the manufacturing process of these important safety elements of the vehicle, using a new type of steel that has twice the tensile strength compared to the previous type of steel. This is very important because if this part is deformed, the alignment of the wheel will be compromised. On the other hand, the ball joints used in these parts are built in hybrid core technology, the new type of synthetic grease and flanged and zinc flake coated nuts. Thanks to those facts, MOOG guarantees the stability and durability of these elements as well as the precision of the steering angles. It is important to note that cataphoresis painting was introduced by MOOG in 2011 for all the wishbone arms, as a change from the wet electrostatic painting process commonly used by most parts manufacturers in the aftermarket. Cataphoresis, on the other hand, is mainly used by original equipment manufacturers. In the electrostatic painting process, the part and the paint are subjected to different electrical polarity to ensure a better process of paint adhesion on the metal. In this case, the paint adheres to the small cavities on the external surface of the part more efficiently compared to the conventional wet paint process. On the other hand, in the process of cataphoresis, the piece is immersed in the paint, also electrically charged, for this is able to cover the hidden areas of it. So the internal cavities and holes of the piece are also protected against corrosion, preventing rust from starting from the inside of the metal part. With the cataphoresis technology, MOOG offers a much better product with excellent protection against corrosion. The paint is thicker and more elastic, so it does not crack, offering a much longer product life in optimal conditions. But what makes MOOG's offering better than its competitors' products? Products in the MOOG Differentiation range have a 3-year warranty. Hybrid core technology is patented by MOOG and therefore unique in the aftermarket. All of the above features such as hybrid core technology, the new type of MOOG synthetic grease, the flanged and zinc flake coated nuts, etc., improve the durability of the product, provide optimum steering control and response, improved driving comfort, and most importantly, easier and faster assembly, as well as offering maximum level of safety of the parts once they are mounted on the vehicle.